Okay, ladies and gentlemen, at this point we're in chapter 6 of our textbook, and before that, I'm your instructor today. I'm Kino with STEMwithKino.com. So today we're going to talk about flight controls, and we're going to talk about the three axes of rotation. Singular is an axis, plural is axes, and we'll discuss that in a moment. So, mechanical flight control systems. Um, if we look into our cockpit, and normally there's some type of control stick, control wheel of sorts. So this is our control stick, and um, let's use this. And, all right, so it moves around and it manipulates certain flight controls. If we come to the outside, we can see some stuff going on as we wiggle the stick around. Alright, so again, I'm just wiggling the stick around, and I am going to continue to. And we will see some things go on with our aircraft. Okay, and let's get a lock spot version, and then we'll come out and we'll go up a little bit, and we will be able to see the aircraft controls movement more pronounced. So this is not typical of most aircraft, because most aircraft actually, the ailerons, which are moving right here, would just be moving. But the flight control system, this is a very super, I'd even say hyper maneuverable aircraft, and so all the parts work in conjunction to make the flight movement happen. So maybe I shouldn't have done it in this aircraft, but at any rate, you will get the gist. These are actually the ailerons, and we have flaps, which will be the inboard surfaces from the wing root to mid wing, and then from mid wing to maybe the wing tip. Sometimes you would have the ailerons. Then you would have your elevators. In this case, look at the thrusters. Look at the exhaust thrusters. They actually pivot to help assist with the pitch of the aircraft, and we'll talk about that in a minute as well. So back to our text. So basically what we have our control stick that's connected to a system of pulleys and cables and push rods that actually move these flight control surfaces. So, and believe it or not, some systems are what we would call fly-by-wire, which you'd have your control input and it's connected through a system of wires and actuators and stuff like that, and it moves stuff around. You could also have a hydromechanical flight control system, in which this might be in this particular aircraft, but just focus on the system, not so much, at this point. So basically, in a hydromechanical system, we have some type of power cylinder. So there's a hydraulic system. Hydro meaning water, mechanical. So there's some type of liquid in conjunction with our mechanical side of things to actually give you a control feel. So as you grab the stick, you can actually feel pressures acting against it and stuff like that to give you a control feel. And this consists of, the same mechanical linkage system that we had up here. But what happens is, and this would be more typical with larger aircraft, because you need some power to move larger flight control surfaces and stuff like that. Here we have the helicopter, all right, and even the helicopters have a control system here, or a mechanical control system here. So we have our anti-torque pedals, which you've seen me in previous videos, is in a collective control, and you can see the pulley systems and how they connect to the main rotor, the anti-torque rotor, and the swash plate. So, there is a lot going on behind the scenes as we look at the airplane. At this airplane, there's a lot that's going on that we don't see. Okay, that makes all this neat stuff happen. All right. So I wanted to jump into the three axes of rotation. All right. So what I'd like you to think about you have, let's say, I don't know if you guys ever eaten a shish kebab and how the stick kind of goes through it. But if we stuck a stick through the airplane, this will be the longitudinal axis. And the aircraft would roll around the stick, if you would. So it rolls about, we say rolling about the longitudinal axis, and the ailerons are what's used to do this. So, I mean, in your text, you can just look at the colors. All right. So you got the colors of the actual axis. All right. So when we look at the axis and the movement, all right, it'll tell you the flight control. So the aileron is what's used to roll the airplane, and I'm going to demonstrate this. But this is the longitudinal axis, and this is the movement about the axis. So blue and blue, you can see the movement. So this rolls. The lateral axis is basically, it runs wingtip to wingtip. And then the aircraft pitches, like if you're driving uphill and driving downhill, driving up and downhill, you're pitching. And then finally we have the vertical axis. All right. And so this is why, or this is how the aircraft rotates in this three-dimensional movement. Okay, it could roll, it could yaw, or it could pitch, and we're going to demonstrate that in a moment here. Something that we have to be aware of in turns. This aircraft is doing a slight turn, and lift and drag kind of play in conjunction, because the more lift you have, the more drag that's going to occur. So even though this aircraft is trying to make a left turn, this aileron is pushing the wing up, this aileron is pushing the wing down, so we have less lift on this side. So since we have more drag, there's like, say, like one fat lady here, but then there's two fat ladies here slowing it down. And even though we're trying to make a left turn, this wing has less drag on it, and then what happens is it will turn right a little bit. And this is why we need to use rudder to yaw. What else? Differential ailerons, coupled ailerons and rudder. Differential. You can read all about this stuff. This is a conventional landing gear configuration, because it's like the older aircraft and more commonly known as a tail dragger. What else? Elevators. I want to just make sure if there's anything else I should cover. Alright, so yeah, so that's basically the takeaway, that sometimes you have a V-tail. Now this aircraft is slightly a V-tail. I guess you could call it a V-tail, because it's not going vertically up and down like most aircraft. So we could call that a V-tail. Anything else I want to touch on? Secondary flight controls are flaps, slats, and I'll do a video. If you guys enter something in the comments where you want me to discuss flaps and slats, we can do that. I guess what we'll do is spoilers. Spoilers, okay. Spoilers actually destroy lift. Now, what happens here is these are like air brakes, more so than spoilers. So I might be doing a two-part of this, all right, because I just really wanted to touch on the basic motions. So yeah, this is going to be like a two-parter. All right, so let's dig in. All right. Let's get our head up. Let's get this canopy closed. And let's get our sound box. All right. So we're in the cockpit. And we're on runway 9 at Elgin Air Force Base, and runway 19. So basically, I wanted to talk to you guys about the basic movements. Now, let's come back to the book. Like, let's go to the book. And let's go to the book. So, yawing. We use our rudder to yaw. All right. And we yaw about the vertical axis. All right. So, let's deal with that. So, as this aircraft as we speed up or apply power, and I'm trying to do it very nice and slow. And in my ear, that's a lot of noise, so I just killed the sound. All right, so as we slightly add power, the aircraft should lunge forward. And I want it to just creep. I don't want it to go nuts. So let's come back in and see what's going on in here. All right, so okay, the throttle is moving forward. All right, so okay, so now the aircraft is beginning to roll. All right, and imagine the vertical axis going up and down. And so what we do is we yaw, and we can see that the rudder is moving. So if we yaw to the left, we use our rudder, and these are our rudder and the vertical stabilizer. All right, so we see it go that way. It's yawing left. It's yawing right. It's yawing left. It's showing right. All right. Okay, so that is yaw. And if we come back to the text, we can see that the yawing is the left and right motion around the vertical axis. Now we're going to talk about elevator, which we pitch about the lateral axis, all right, and we roll about the longitudinal axis. So we're going to explore that now. All right, so we come to a side view, and we're going to deal with pitch. That is like pretty much the first motion, pitch and yaw. We yaw to maintain orientation over the runway, and pitching is going to be first. Now I'm doing this third person, so don't go nutty if but I'm trying to get you guys to understand pitch. All right, so you know what? Maybe because the trolls will talk. They'll be like, "Man, look, he made a mistake." Says I wasn't in the cockpit. That's why. Okay, full power. Airspeed live. Engine instruments check. Right. Rotation. Let the aircraft aerodynamically take the weight off the wheels. Isn't that pretty? Okay. Take the man power out. Okay, so basically we're going to talk about pitch. Pause for a moment. Again, when we pitch about so imagine from wingtip to wingtip, there's like a what do they call it? A shish kebab, or one of those little skewers, and you boom, and you stick it through there. Then the aircraft will be subjected or restricted to a pitching moment, and we use the elevators to pitch. In this case, this aircraft has a stabilator. So, like, in this elevator, just this back part moves, but in the stabilator, and I know I do have the whole control surface moves in the stabilator. So you don't have a horizontal stabilizer anymore. Like in this aircraft, you have the horizontal stabilizer, and then this actual part moves with the elevator. But in the stabilator, or stabilizer, some people call it, the whole control surface moves. And that's another reason why it's got so much damn maneuverability. All right, back to the flying. All right, here we go. So we're pitching. We're pitching nose up about the lateral axis, and we can pitch nose down. And you can see that the stabilator is moving. When the stabilizer moves up, the nose goes up. When the stabilizer goes down, the nose goes down. This is weird flying it like this without, being actually behind a control panel. Okay, now we did touch on adverse yaw. Let's talk about adverse yaw. Now, in adverse yaw, now in adverse yaw, if we were just to, this is the reason why we need rudder. If I was just to bank the aircraft like this, notice it doesn't really turn very much, does it? And let's go to an outside view. Alright, so if I just go ahead and let's get a reference. Always have a reference, visual reference. See this cloud out here? Okay, well, if I just bank the aircraft, it doesn't turn very much. It turns slightly because this wing is producing more lift than this one. It's producing more drag as well. So a little bit of rudder and aileron is necessary in order to turn this thing. All right, so I know that was like a lot and very sudden. So let's explain what I mean. All right. So when we were banking the aircraft, we were banking to the left. This wing went up and the right wing goes down if we're in the left bank. So the more lift we get, the more drag we're going to get. All right, induced drag anyway, because induced drag is a byproduct of lift. So the more lift that we create, the more drag we're going to create. And as a result, even though we're trying to make a left turn, it won't happen unless we counteract with a little bit of aileron and rudder and elevator. So it's coordinated flight. Okay, it's not just one control surface doing this thing. It's coordinated flight. So we have our ailerons playing with our elevators and playing with our rudder. All right, back to simulation. Now, in this case, if I want to really turn, I'm going to put some elevator in here. Okay, let me do that. All right. So we're rolling now. And now we're pitching. Nose up. Pitch nose up. Pitch nose down. Pitch nose up. Oh, let's not get crazy. What's our altitude? Okay, yeah, we still have 3,000 feet of altitude. Alright. So we're that bad. Alright, so let's go back to Elgin. Return to base. Now we have a heads-up display. On most aircraft, we actually have a control panel that we need to look at. But in this case, we can keep our head up and in tune with what's going on outside. Bang. Wrangler is really, really nice, I gotta say. So at this point, what we'll do is we'll just put it down right there. Alright. In fact, let's work with some other runways. We all do the same runways. Let's try something different. Okay, landing gear extend. Man, the detail that they put in this thing is like beautiful. Okay, there's our gear. There is our runway. Now, normally you would plan your approach. This will be more planned, and since this is the simulator, we can, play with it a little bit, kind of like a video game. But you would not shoot an approach just cold out of the blue like this. Definitely do some flight planning. Oh, still okay. That's so you can see when your approach is not planned properly, you can see how it can be a little bit of work, kind of getting yourself back on track. So you never ever want to shoot an approach like this, because it takes a lot of skill to just kind of get her back where you need her to be. Got the runway made. Touchdown. Launch gear is down. Okay, so we talked about the 3 axes of rotation. Okay, so the 3 axes of rotation is what we covered in this video. We pitch with the elevators about the lateral axis. We yaw with the rudder about the vertical axis, and we roll with the aileron around the longitudinal axis. When we say axes, it's plural. It's like tomato, tomatoes. All right, so when we talk about singular, it's an axis. It's one axis. But when we say multiple axes, tomatoes, axes of rotation. We also talked about adverse yaw. I was thinking about a 2-parter about T-tail design, mechanical controls. We discussed that in our recap. We talked about the V-tail just a little bit. So the next thing we're probably maybe I don't know what we'll do in the next lesson. We'll talk about autopilot. Okay, so the chapter summary. See, as it applies to us. Because flight control systems and aerodynamic characteristics. Why did that pop up? Okay. I gotta get rid of that. I don't know why that does that. I'm very sorry, folks. So, because flight control systems and aerodynamic characteristics vary greatly between aircraft, it is essential that the pilot become familiar with the primary and secondary flight control systems of the aircraft being flown. And the primary source of this information is the aircraft flight manual or pilot's operating handbook. That's what we refer to when we talk aircraft flying manual or POH. All right, so that's it for today, folks. I hope you guys enjoyed the video, and let's go out with a bang. Let's see. And this is simulator land, so don't try this at home, folks. We don't have a whole lot of runway, so let's see how strong these engines really are. And let's go to a top-down. So this is why you don't do, well, what am I trying to say first? Let's get a top-down view. So if you look here, we landed on this runway, and we're right about here. So we don't have a lot of runway remaining. All right. So we landed here, and now we're kind of like here in the middle, and we don't have a whole lot of runway remaining. Yeah, you know what? I should do airport markings. That'll be a great video as well. All these ideas. Okay, so let's unpause and back control. Oh, that's because probably. Let's come on now. And let's see if this thing will take off with the remaining runway. If not, it will be in a drink. And this is why you need a certain amount of runway to get a certain amount of airspeed over the wings, or you could be in trouble. So this is a demonstration of what not to do and why some aircraft need a lot of runway. Okay. Stand on the brakes. Pull afterburner. Whoa. Well, I think this aircraft has the guts or packs of air to do it. Okay, let's have a victory roll. See you guys later.